Good morning, everybody, and welcome to the first Clean Lakes 101 Science Cafe of 2022. In case we haven't seen each other in the last couple of years, I'm James Ty, the Executive Director of the Clean Lakes Alliance. First, before I get through my speech here, I would like to give a shout out to Luke Wynn. Luke Wynn is the guy behind the scenes that makes our educational programming come together. And just really thankful to him and the entire team that makes this possible. I'd also like to thank our sponsors, both First Weber and Johnson Financial Group. They are the presenting sponsors of these annual talks. A big shout out to them. I'd also like to recognize our hosting sponsor, the Edgewater. We hope to be back there soon in 2022 in person once it's safe to gather again. And don't worry, we'll be having a hybrid program for those of you who are not in the greater Madison area, or even if you are, you can tune in. Our supporting sponsor is National Guardian Life. Our production partners are the UW Nelson Institute for Environmental Studies and UW Extension Lakes out of Stevens Point. And of course, our media sponsor, WKOW. Usually nowadays, it's Max Saparius, the meteorologist from WKOW, who's emceeing these talks, but he's taking so much time off, deserved time off, excuse me. We're excited to bring a new slate of speakers in 2022, hopefully increasing everybody's knowledge about the lakes and the watershed so that we can all enjoy them even more. But before we get to today's talk, I'd like to thank everybody who was a friend in 2022 or a business lake partner. We're really grateful for all those, and we actually beat our goal. So now we have even more money to do lake projects, educational events, and programs like this to help advance cleaning up our lakes. But now that it's a new year, it's a new campaign. So please go online to cleanlakesalliance.org/donate and make that donation. Every dollar counts. Earlier this year, we get donations throughout the year, but really it makes it helpful to me as executive director to get those dollars early in the year rather than waiting to the end. But all donations are good. Before we go on with today's talk, I want to introduce my friend, Julie Bauer, who's pretty special to the Clean Lakes Alliance. She was one of the first people we talked to way back 11 years ago about starting the Clean Lakes Alliance, and thankful to have her today. The Alliant Energy Foundation is this month's talk sponsor, and Julie is here to tell us more about today's topics, the speaker, and how Alliant Energy is involved with the Clean Lakes Alliance. Welcome, Julie.
Thank you, James. Good morning, everybody. Alliant Energy is always excited to support these talks and a number of other Clean Lake Alliance programs and events throughout the year. At Alliant Energy, we have a long history of trying to do the right thing to protect our environment, our lakes, and all of the beautiful places that make Wisconsin, Wisconsin. Through our Clean Energy Blueprint, we're focused on creating a more sustainable future for our customers and communities. For example, since 2005, we have reduced the amount of water we use by 66%. We're also poised to become Wisconsin's largest owner and operator of solar energy production in the state. And last year, we announced one of our biggest initiatives yet, 1 million trees. By 2030, Alliant Energy is committed to planting 1 million trees in Iowa and in Wisconsin. That's roughly 1 tree for every customer we serve. Once again, Alliance Executive Vice President, General Counsel, and Corporate Secretary Jim Gallegos will serve as Clean Lake Alliance's Executive Board Chair. Before I get to today's talk, I wanted to remind everybody that the lake is frozen, which means frozen assets is right around the corner. Visit cleanlakesalliance.org today for a complete schedule of events for the family-friendly Frozen Assets Festival on Saturday, February 5th. You can see it up on our screen. There's a way to sign up for the Alliant Energy sponsored Frozen Assets 5K Run Walk. which, mind you, is the only 5K in North America held entirely on a frozen lake, which is pretty darn cool. So back to today, where the title of the talk is Changing How We See Algal Blooms. This past summer, Clean Lakes Alliance volunteers participated in a long-distance collaboration with BloomOptix, a group focused on innovating how we monitor and study harmful algal blooms by leveraging emerging technologies and methods. Equipped with portable digital microscopes generously shipped all the way from London, company Iolight, volunteers collected microscopic images of algae and cyanobacteria cells. These images are being used to train an AI mobile app to quickly differentiate between harmless green algae and toxin-producing cyanobacteria. Presenting on this technology and some of the finding is Igor Mrdjen. Mrdjen leads BloomOptix and has a research background in environmental health sciences. He has led, designed, and conducted research on various water quality and health phenomena. Finally, just a quick reminder to please submit your questions early using the Q&A function so we can make sure we get through as many as possible. With that, I'll turn it over to Igor.
Thanks for that great intro, Julie. I am going to share my slide set. 1 second here. Alrighty, I'm going to assume that everybody can see my slides. And first of all, I'd just like to thank you all for having me. It has been a pleasure working with the Clean Lakes Alliance on this project. And yeah, as Julie said, my name is Igor Mrdjen, and I'm the lead scientist at BloomOptix. And today I'm going to be talking to you guys about our efforts in trying to change how we see harmful algal blooms in our lakes and how we are working to empower the good old regular citizen scientists that we all really heavily rely on. So the outline of the talk today is going to be pretty straightforward. I'm just going to take a second to discuss what harmful algal blooms are for some of those on the call that might not be familiar. I'm going to introduce BloomOptix and who we are, what our mission is, and what we stand for. And then I'm going to discuss the 2 topics of the day, which is how we are trying to improve traditional HAB study methods and how we are trying to empower the citizen scientists into having a greater contribution than they already have. So with that, what are harmful algal blooms? So harmful algal blooms, or HABs, as we like to refer to them, in short, are basically just extreme growths of cyanobacterial or algal communities in waters. And they basically take over waterways, producing a pea soup appearance in freshwater lakes, and more commonly brown and red tide in the marine environment. Along with these HABs come a series of consequences or negative impacts onto the water bodies they affect. The first one that most of you might be familiar with are hypoxic cells. So what happens is these communities of cells are, excuse me, are so overrun the waterway so extremely densely that once they die off towards the end of the algal bloom, they sink down to the bottom of the lake where they are decomposed by natural processes. And this decomposition actually saps the oxygen out of the water, producing low oxygen zones in the waterways, which can lead to fish deaths and overall just negative impacts on the ecosystem within these lakes. In addition to that, some members of some species and genre of these harmful algal blooms end up producing various different toxins, including neurotoxins, hepatic or liver toxins, and then things that will really mess up your GI tract if you were to consume enough of the water. On top of that, there are because of all of these different issues, there are various economic impacts associated with harmful algal blooms, including beach closures in places where waterways are used recreationally, harm done to fish communities, which can really impact recreational fishing, and then things like disruption of food supplies in marine environments where shellfish are being raised and farmed and so forth. And then on top of that, they're just plain ugly and it not great to see on your lake. So what we see is a lot of aesthetic impacts as well as stigmas attached to lakes, because once people get the idea that, oh, this lake is seeing a lot of algal blooms, that water is dangerous, they are much less likely to come back and visit that same lake and use it recreationally. Or if you live nearby in that lake's area, you are going to be more likely to be basically turned off by to the idea of visiting that lake because of these algal blooms. So because of all these reasons, it is important to get a sense of what exactly is going on and tackle this problem statement head on, and get a sense of how we can prevent exposures to these toxins, how we can get more data, more information on what makes these blooms tick, and how we can basically reduce their impacts on our society, on our health, economy, and so forth. And so traditionally, the way we have studied harmful algal blooms has relied heavily on things like the involvement of volunteers or citizen scientists or field work, where we basically go out, we observe the clarity, color of the water and any formations that may be apparent to the naked eye, or we put sensors into the bodies of water that passively measure water quality and then report back to one or two observers on shore, which then they compile into big scientific data sets and create and generate all of these different conclusions and findings. Additionally, in the past couple of decades, we've been more and more reliant on the use of satellites in monitoring our harmful algal blooms in a way that basically what we're looking for is what color reflects off of the body of water and up into the satellite. And by looking for a very specific light reflectance signature, we can say that, hey, this is an algal bloom, it's at this position now. So we can take basically very, very large surveys of land and water and monitor harmful algal blooms on a very large scale. So what are we at BloomOptix doing about this approach? Well, the team is made up of myself at the top and some representatives from Ramble, our parent company, and as well as two separate teams. One's dealing with remote systems, our UAV operations and ROV operations, and then ecologists and AI experts working with us on HABalert, which is the project that we hinted at earlier in the talk. And our mission has always been to take all of these different functionalities and sets of data available to us and make the decision makers' jobs a little bit easier by enabling them to conduct intelligent decision making based on either dense data sets or rapid data turnaround times, and just basically allowing us to be more informed and more efficient in how we operate our beaches, drinking water intakes, and lake management strategies. So the way we set out to accomplish this mission is by improving upon the traditional HAB study methods that we have. And so what we're doing is we're taking that historical data that we have and adding in advanced monitoring methods to create these robust data sets that can aid people in making decisions based on high quality data that can that can act in the long term and in the short term. So we're looking at making data over years and years, and as well as on a day-to-day basis. So one of our typical projects basically involves going out to a lake that is either experiencing an algal bloom or is likely to experience an algal bloom. And the first thing we do is go there and we observe the water with just regular good old eyesight to see if anything is congregating on shore. These blooms tend to get blown into shore by wind action. And so one of the first places you'll see is these blooms is on the shoreline. The next thing we do is we fly out and collect water samples with our fleet of UAVs or drones. And we can basically fly out thousands of feet offshore and collect the water sample and bring it back within a couple of minutes and test it right off the bat. And then in addition to these water sample collections, we can actually get imagery from the air with specialized cameras that will enable us to get a visual sense and basically a weather map type of display of the water of where these harmful algal blooms are located. And so here in the background, you can see our drone carrying water samples, as well as our big drone that is equipped with a hyperspectral camera that can give us an idea of what the water looks like and what the bloom formations look like in terms of intensity and location using advanced imagery. So the other thing that we conducted this summer was tying in our unmanned ROV into this operation. And basically what we can do is we can attach a sensor payload onto this ROV and get a sense of what these algal blooms look like, not only on the surface of the water using our cameras, but also at different varying depths. And this ROV basically measures for all of the algal pigments and so forth, and different water quality parameters such as turbidity, temperature, and all of the common things we normally look at in these water quality studies. It can also basically track itself using GPS in its position. And what we're doing here is basically every time we get a reading, we ping back that GPS location for ourselves. That way we can take that data and layer it on top of the heat maps that we see using our UAVs from the air. So what we're doing is we're basically getting data from the water itself. We're getting meteorological data from onshore to draw conclusions from, as well as that bird's eye view of these algal blooms that are taking shape in our bodies of water. And so here, what we can produce are images and figures like this, where you get to see a very nice, red, blue, green gradation of bloom intensity in our bodies of water, but then also get some additional data on top of it, how that relates to the sensors we see, how that relates to lab data, and then basically draw conclusions and advanced models from that research. So one of the things that we noticed while we were working within BloomOptix was that, all of this stuff that we're doing with UAVs and ROVs is really cool and interesting, and we love to do it, but it's a big commitment on our part from a logistical and time perspective. So basically, any place where we want to do these types of studies, we have to be there physically flying the UAVs. We have to be there physically operating the ROVs and so forth. So one of the issues that we have with this is not only are we logistically constrained to certain parts of New York State, but the cost of these types of operations is fairly high. So we wanted to work on a solution that basically can be deployed anywhere and empowers the average citizen scientists that so many lake associations and different organizations rely on heavily to gather data. So basically what we noticed was that today's HAB monitoring methods fall into roughly two categories. There are the HAB monitoring methods, which have a very large budget and can utilize all of these different resources. And then there are the HAB monitoring methods that are basically run on the goodwill of their volunteers and have very limited resources. So on the one hand, you have methodologies where people go out and sample water every single day, or they deploy these very expensive sensors in bodies of water to get daily information and draw information from. And then on the other hand, you have folks that are basically telling their citizen scientists, anytime you see a watercolor change, call us or text us or email us, and we will go check it out or collect the water sample to send to a lab. So there are a couple of disadvantages to both of these methods. First of all, the sheer expense alone and buying the necessary sensors and organizing all of these volunteers and everything are immense. So one set of sensors can cost upwards of tens of thousands of dollars, and then there's yearly maintenance and so forth. The second disadvantage is every time you see a harmful algal bloom or anything like that, you have to collect a sample, ship it to a lab. They have to analyze it and then confirm whether or not, one, that was a harmful algal bloom in the first place, or two, they will confirm to you at what concentration that algal bloom occurred. And so all of this exchange of information and samples and everything can really slow things down and take multiple days to process and result in response times, which in a lot of cases is just not quick enough. And we really need to speed up that process. On the other hand, when it comes to citizen scientists, what we've seen is that a lot of folks will report a color change in the water and, oh, well, it'll dissipate. It'll either dissipate fairly quickly, or once we deploy somebody out there to check it out, whether it's on a boat or on foot, the bloom has moved, or the bloom is just, regular green algae, and it is not a harmful algal bloom, which we would consider shutting down a beach for or activating advanced water treatments for. So basically, we set out to create the ideal solution for this type of problem. We wanted to create something that is accurate, mobile, and compact. So basically, you can keep it in your pocket and take it anywhere with you, or at least by your side. And we wanted to do something that was very user-friendly, where anybody from a high school trained lifeguard on a beach could use it, all the way up to a PhD level researcher in an analytical lab. We also wanted to enable people with frequent sampling capabilities, so that if you are a lifeguard on the beach, what you can do is you can go collect the water sample, have it analyzed within a couple of minutes, which ties into the rapid analysis capabilities, but have that sample analyzed fairly quickly, and then go collect another one, and then another one, right? And then follow up throughout the day and never have to stop. So you can have very periodic sampling to see when that bloom is at its highest, when it is subsiding, and then you can basically dynamically open and close beaches and dynamically monitor the situation for these algal blooms and what's going on in your bodies of water. And so with this, we didn't want to focus just on watercolor because, number one, those sensors tend to be fairly expensive, but also don't tell you the whole story. Just because your water turns green doesn't mean it's turning green because of cyanobacteria or because of algae. So it's really more information is needed to draw conclusions from the data that we're getting. So we wanted to focus on cyanobacterial identification to give us an idea of what is causing the bloom and the concentration in which they are occurring. So we can basically establish thresholds where the decision makers are comfortable taking certain actions or not. And then along with this, we really wanted to top it off with something that can enable rapid dissemination of findings, so that if you do see a harmful algal bloom, you can report it fairly quickly, and it blasts out warnings or whatever messages or whatever types of hey, heads up to either the stakeholders or the decision makers within that area. And this way we can act quickly and be very responsible for the health of the ecosystem, the recreational users, drinking water operators, and so forth. And finally, we wanted this platform to be ever evolving and growing in terms of capabilities, because as we learn more about harmful algal blooms, we actually will need to tweak and change the way we operate and what to look out for in terms of this type of product. So our solution to this problem has so far been HABalert, which is what we are calling the little project that we conducted this year with the help and support of the Clean Lakes Alliance. And basically what it does is it uses the Iolight portable digital microscope, which hooks up to your phone using Bluetooth or Wi-Fi. And you basically are using this microscope to take pictures of the organisms in your water. And once you take those pictures, they are uploaded to HABalert, where they are analyzed by experts. So what we're doing basically is we're taking that traditional harmful algal bloom cell counting and ID time of having to ship your samples to a lab, having an expert analyze that that sample and returning results to you and reports to you from about 24 hours to up to 5 days, or even greater in some cases when there's a lot of backup, down to about 10 minutes or less once we get the AI up and running. And so basically what you're doing is you're collecting a water sample, imaging it using the digital microscope, and then uploading the images to us, where we analyze it using our AI and let you know whether or not you have cyanobacteria in your water sample, and then at what concentrations. So this past summer, we wanted to put this idea to the test. It's all nice and great to have these ideas, but if it doesn't work practically and in the hands of the typical users, it's really kind of pointless to even talk about. So what we did was we deployed our microscopes to 9 different volunteers across Wisconsin and New York State. And these volunteers acted as our users, or clients, as we called them, throughout the study. And they submitted images, weather data, and even water samples to BloomOptix for us to analyze and image and go through. And then these submitted images were basically processed for cyanobacterial IDs and cell counts, as well as being archived for AI development. For the purpose of this pilot study, we wanted to do cell IDs and counts manually. That way, we ensured that, first of all, we, the experts, could see before we invested a bunch of time into AI development, but to see whether we could see these cyanobacteria and basically demonstrate the usefulness of these microscopes in this program to these watersheds. So we ended up getting water samples and images from 22 different lakes across New York State and Wisconsin. And what we did was, in return for those images, we gave our participants or clients results within about an hour and a half on average. So even if going from a 24 to 2 day turnaround time that you would see with your local neighborhood lab, that is a real big improvement. And so our clients also got a confirmation of whether a bloom contains cyanobacteria belonging to the Microcystis or Dolichospermum genre or not, and then the cell concentrations within these images, as well as the ability to frequently sample their bodies of water, so that when they would email us the images and upload them to us, they could already be out collecting the next set of images and submit it to us as well. And I should say that the reason that we selected only Microcystis and Dolichospermum to go after is because those are the 2 most common genre of cyanobacteria that we usually see in the Great Lakes region. And so from here, what we wanted to do was we wanted to take a bunch of this information and compare it to compare HABalert to how the standard Fluoroprobe analysis works. So a Fluoroprobe is basically just a fancy light sensor that you insert into a water sample, and it tells you what types of different colors are found within your water sample. And traditionally, it's used in cyanobacterial and HAB monitoring to tell you the relative amount of color associated with cyanobacteria within your water sample. And it's a very quick and easy analysis. You basically dip it in, press a button, get a reading kind of thing. However, the Fluoroprobe is very, very expensive. And so it is usually limited to folks who can afford to have one, and takes some training and skill to operate and interpret, more importantly, interpret the results. So what we wanted to do was compare how HABalert counted and enumerated cyanobacterial colonies to what we were seeing in the Fluoroprobe analyses. And what we found was, there was a really strong correlation and really good agreement between the two methods, meaning that what we were doing and the data we were producing for folks like the Clean Lakes Alliance and our other volunteers was actually representative of what they would have seen using a Fluoroprobe in their bodies of water, but using a system that would cost much, much less in the end. So what we learned through this experience and working on this HABalert pilot study was that our platform is fairly user-friendly at all experience levels. We actually had really positive feedback from the folks that work with us. And after we got through a couple of technical issues, we actually saw that, once everybody was used to the microscope, all it took was an hour or so of training for them to get going and start submitting samples. And then what we also saw was, even with human intervention, even with processing the results manually, the results turnaround times were really rapid and much improved in terms of turnaround times and data than having to send your samples to a lab, having them process these samples, and then waiting 1 to 2 days for results to come back to you. And so basically, what we showed was that even using the manual version of HABalert, we can enable more timely decision making at the beaches where we deployed. And then we also saw, like I mentioned earlier, was that the data that we are producing is strongly in agreement with the Fluoroprobe analyses that we conducted, and basically is equivalent to doing the same analysis with a Fluoroprobe, except we're not just telling you, oh, this color is this color is found here. We're actually telling you what types of organisms can be found in your water samples. And then finally, the encouraging thing was we noticed that the most time we were spending during results turnaround and sample processing was actually physically tracing these cells and these colonies by hand. And so if we replace the human component in this process with an AI that we can develop, we can actually get that response time down to less than 10 minutes. And by including this AI component, we can actually basically infinitely scale. So we can give a lake association or stakeholders, 30 microscopes, and they can all be submitting samples at the same time and getting those samples turned around basically in real time, making those decisions very quickly. And finally, the last thing we saw was that if we can get that AI going, we can actually expand to other types of cyanobacteria, even marine algae, to tackle those red and brown tides, and even bacteria if they are recognizable enough and our magnification is high enough. And so basically the possibilities for expansion of this type of applications are endless, because as long as you can identify things in a unique manner, and as long as you can get them onto the photos with a microscope, you can basically apply this type of methodology. And so our project goals for the next year are basically to keep collecting a bunch of data and finalize our AI and validate it against the established methodologies, and then launch another pilot and testing study. But this time, instead of processing samples by hand, we would actually process them with the AI itself and see how that performs. This past year, what we were really focused on is seeing how this platform behaves in the hands of the users. And we are really, really thankful to have worked with the Clean Lakes Alliance and all of our volunteers because we were able to collect 15,000 images of cyanobacteria across those 22 lakes. And so the really nice thing is we have a ton of data to work with. The really bad thing is we need to go in and process 15,000 images. But once we get through that process, I think we will be back again to see if we can get this AI working and launched across our various different lakes here. But in the grand scheme of things, working within BloomOptix and talking with all of the folks that we have interacted with over the years, what have we learned in terms of HAB monitoring, and what conclusions have we drawn? Well, the number one thing that we found is that algal bloom monitoring can really benefit from advancing technologies, whether that's AI building or whether that's the use of different hardware. We really think that there is a future in applying these advanced techniques and technologies to harmful algal bloom monitoring efforts. We also found that, if you can tie in drones and satellites and different unmanned systems, you can really expand large-scale HAB monitoring and study efforts to where basically you can measure, you can detect and study long-term and large-scale HAB movements and dynamics. But then if you take it down to a smaller scale, if we can combine accessible and near real-time monitoring technologies, then we can really empower the average citizen scientist to the point where we can produce very reliable, high-quality data that they then can have a much, much larger contribution to science and our HAB monitoring efforts across the board. So with that, I think we can move on to the questions and feedback. If you would like to reach out to me or get in touch with BloomOptix, my email is up on the screen here. And I'm sure we can share it in chat or something. Yeah, we welcome all questions and feedback. And even if you just want to sit down and talk HAB monitoring or HAB efforts, we are more than happy to do so. So with that, I think I will turn it over to Adam, who will moderate the question and answer session.
Yeah, great. Thanks, Igor. Fantastic talk. We've got a whole slew of questions coming in, and remind everybody that continue to use that Q&A function on the bottom if you'd like to have your question answered. A couple of questions. I'm just going to try to rip right through them here. The first one that came in, someone was saying that not all cyanobacteria produces toxin. Will the AI app distinguish between toxins produced and non-toxin producing types?
Sure, that's a great question. So one of the things, that's exactly right. Not all cyanobacteria produce toxins. What we have seen through our work is, and the reason we selected to go after Microcystis and Dolichospermum is that those two genera are the most commonly associated with toxin productions in a lot of the lakes that we see, and especially in the Great Lakes region. So that is kind of our attempt to say, if you see this, then you should be a little bit more careful about your harmful algal bloom. However, I don't think we ever want to be at a point where we are telling people that, oh, because you see this, there's definitely toxin in the water, or because you don't see this, there's no toxin in the water. The dynamics of toxin production and cyanobacterial relationships are just so complex that I don't think we are there. We still don't know why cyanobacteria produce toxins in the first place. So that is a very difficult relationship to assess. However, if you do have a toxin monitoring program, this can make it a little bit more efficient, right? So if you build enough data on the back end and you say, every time we see Microcystis, we see that a spike in toxin X amount of days later or something like that, you can use this as a screening method to see harmful algal blooms. And on top of that, just because toxins aren't being produced doesn't mean that there is no harmful effect of these blooms on the ecology of your lakes, or on things like aesthetics in your lakes, right? So some folks have harmful algal blooms, but they never produce toxins, and they would still like to take care of it because nobody likes to swim in pea soup green water, frankly. So we're trying to provide a solution that kind of satisfies a certain need, but can also be used in conjunction with other analyses methods that can really provide a ton of information.
Yeah, great. Well, so, over the past summer, you did work with our Clean Lakes Alliance volunteers with Lake Forecast. I'm just kind of curious, did we learn anything about some of the timing or frequency? Have we been able to synthesize that data yet and come up with anything?
The timing and frequency in terms of
when
algal
an algal bloom would happen,
right. So this was a really weird summer for algal blooms across a lot of the lakes that we studied. Some folks had an algal bloom every single day, and at that point, it's really difficult to draw any conclusions about algal blooms. And then some folks had basically so much rain that anytime a bloom was about to form, it would rain and it would break up the colonies, and then nothing would happen. So what we saw across a lot of the lakes was just a really weird summer, basically. So no, the short answer is no, nothing yet. But we're hoping that with more data collection, and then as we get the AI going, that's going to become infinitely easier to collect those data. But we're hoping that with more data collection, more monitoring of things like weather patterns and so forth, water temperatures, we can get a better sense of what is kind of linked with these spikes in cyanobacterial colonies.
And that kind of leads into an interesting question is you'll learn maybe once you get more data, how the weather affects it, how temperature, everything affects it. How can the data actually help reduce the problem if a number of the inputs are, they're controlled, but a little bit in the immediate term uncontrolled?
Right.
We can reduce carbon, but it's going to be a little bit harder for us to change our weather patterns immediately.
Yes, exactly. Yeah. So one of the things that we are always kind of preaching is this holistic approach to harmful algal blooms, right? You can't address one thing and fix the whole problem, right? The problems are so complex, and it's just such a mesh of networks of causes and triggers and so forth that we really have to look at lakes holistically. And one of the best ways to do that is to have these monitoring programs to see what is potentially triggering your HAB events, and then also to monitor that, hey, we fixed some of the sewer issues around our lake, and now there's less nutrients flowing in, so we saw a reduction. Or hey, it didn't work, it must be something else that is the critical driver, right? So these monitoring programs can really help you kind of pick out the suspects of what could be causing your algal blooms, and then see what's working and what's not working when you start employing these methodologies.
And so I guess that kind of leads into another question is, right now you're able to monitor them. Is maybe the long-term goal to be able to kind of forecast them a little better and say, hey, look, we think within the next 2 days it's going to happen?
Yeah. So our overarching dream vision, let's call it, right? Long-term vision is to use this technology to basically not only give you fast results, but also gather data as results are coming in for each lake and each area and each watershed, and say, based on these parameters that the user provides, we can give you sort of maybe not a risk level, but a heads up to say, hey, based on these things, you might have a bloom in the next couple of days or something like that. We also have a more longer term risk analysis idea where we basically would use climate change models and different variables to say, this is what it looks like today. Here's a monitoring action for that. But then we can also help you out in planning for 10, 20 years down the line with climate change patterns and certain predictions based on NOAA research and all these other factors. So we're trying to give people, to arm them with information to be ready and these tools to make the right decisions for their lakes today and then in the future.
Right.
So
It's an interesting question. Something I think a lot of us have dealt with here in the last couple of years. Testing, we're testing ourselves at home a lot for COVID-19, and there's the, was it a false positive? Was it a false negative?
right.
How is there control for this in the field? Do you have field data on false positives and false negatives, and is there a percentage rate at that to kind of better understand?
Yeah. So not yet. That is something we are going to be doing heavily here in 2022. We had this idea and turned it around and got the Clean Lakes Alliance and everybody involved within and executed the whole study within a period of about 6 months. So we have not had the time to, go through all of the data and actually determine the accuracy, sensitivity, all of that kind of stuff of these assays. So that is definitely next on the list. What we wanted to establish for this pilot study was, number one, is this something that the average citizen scientist can use? And then is this something that actually works practically in terms of gathering images and analyzing them? And then is our model telling us what we want it to tell us, right? So the next step is now taking everything we've learned, making that AI, so then we can take hundreds of data points and run them against the water samples that we collect, and determine exactly that. So
in our lake forecast volunteers, we have roughly 70 points around all 5 lakes. Is it something that, once we get this data, you would want to expand it to all 70? Are some of them just so close that having all 70 of our volunteers equipped with this technology, there wouldn't be enough difference between 300 yards to really matter? Or is it? I don't know.
So it depends. And this is why we have a philosophy of, we don't care how you use it, basically, to put it bluntly. We just want to provide people the tools that they could use to make these informed decisions. So whether you want to have 70 different scopes on a lake and deploy them to all the volunteers is one thing. The other thing that we saw this summer is some of our volunteers and folks had the scopes in a central location. And whenever somebody suspected a bloom, they would take a sample and take it to that place and just tell them where they found that bloom, right? And then we could confirm whether or not it was a cyanobacterial bloom or not. The important thing for us is that we don't want to tell you how to run your lake program, nor do we want to pretend like we know more about your lake than you do. And in a lot of times, a lot of these data sets and observations recorded by citizen scientists are a lot more informative about lakes than we know offhand, just based on biology and things like that. So what we want to do is just empower people to be able to make these observations and do these kinds of tests without getting in their business on how they're using it, right? Whether you want to have it on a boat and have it ride around collecting samples all day long, that's totally fine with us. Or if you want to have it in a central location or just in everybody's hands, that's totally fine by us.
An interesting question, sometimes gets touchy, but I think it's interesting anyway. It's such an interesting process here. Funding is always the big question on anything. Where's the funding coming from right now? And is there, is in plan A, there's this, but plan B is, look, we think that, government agencies or nonprofit, what is the sort of the business model, I guess, the business end of it?
Yeah, that's a really good question. So far, BloomOptix basically invested some all the labor and all that stuff to develop the solution based off of some startup money that we won from the Commercialization Academy here in New York State, based out of the Griffith Institute. And we took that money to kind of do the client validation, the ideation, all of that kind of stuff, to develop the back-end stuff. And then we also worked with the Milwaukee Water Council to get some pilot funding to test this technology in the hands of users, working with the Fund for Lake Michigan. And that enabled us to get these microscopes into the hands of users in Wisconsin and across New York, and really get down to the nitty-gritty of the data. Going forward, what we're hoping to do is basically work these microscopes into monitoring programs where maybe there's some sort of very inexpensive subscription model or something, and get these data into the hands of users. And so basically what we would do is you would probably pay for an annual license or something like that. And then you can use it as much as you want or as little as you want. Quite frankly, it's the same to us, whether you test every 10 minutes or once every 10 days.
Right.
And so that's the business model that we are most likely to go after in the future. Whether that changes or not, I can't really tell.
Sure.
But yeah.
A couple of people also have asked, just, what's the cost of the equipment? Just, one alert scope, like, if we're looking to put them in the hands of people, or someone wants to buy one for their own home, like, what are we talking here?
Yeah. So the technology is getting cheaper and cheaper every day. With that being said, it is fairly cheap right now compared to what the other platforms are. So a Fluoroprobe or these advanced sensors can cost tens of thousands of dollars. We're looking at about $1,000 a microscope. And like I said, these things are really hardy. They're you can take them. They're about the size of my hand, right? And you can take them anywhere you want. And they're mobile, so you can really deploy them anywhere. So yeah, for that $1,000, you can have the microscope. And then we can work out how much your data demands are to figure out subscriptions. Right. We're not really sure what our server costs are going to be or anything like that. So I can't give you a price quote or anything like that for the HAB alert aspect of it. But the microscopes are fairly inexpensive, and we're working with Iolight, the producer of them, to see if we can get them in people's hands for even more affordable price. So.
Are they able to be produced at a fairly good rate, or is this something like everything else we're dealing with right now, whereas the microchip processor shortage is?
Yeah, that's a good question. That's a better question for Andrew, the CEO of Iolight. I think we can produce them fairly quickly. Yeah. But like you said, with everything going on right now with chip shortages, who knows at this point? I will say that we do have about 15 or so microscopes in our possession. So, that's something we can work with already. But, for the foreseeable future, what we really need to do is get that validation testing done this summer and, get it into the hands of volunteers again and see if we can, get them some meaningful data on how well it works with the AI.
So just to put a bow on this, ballpark, about $1,000 to get the things you would need to monitor. Ballpark.
Yeah, about $1,000 for the scope, and then I'm not sure what the subscription to use HAB alert would cost in the long run, but yeah, right. I can promise to update everybody once we do know that. So.
Yeah, sounds good. A couple other questions here. Someone said, once we have we know that there's a harmful algal bloom. Is there anything that this helps to address to mitigate the toxins once they're identified? Is that?
So that is kind of the holy grail of HAB science and research and just the business side of it, frankly, is having a mitigation effort or technique that once you see these toxins, you turn a switch on and magic happens and the toxin is gone, right? The problem with these toxins is they are very, very hardy. They are difficult to destroy, and they are so pervasive throughout the water column that even if we could destroy them, and we do have techniques to destroy them, it is very difficult to scale up. So the best plan of action right now is if you detect the toxin, you just stay out of the water, right? And the best way to mitigate the formation of the toxin, as far as we know, is to reduce the appearance of harmful algal blooms and these colonies in the water column. And the best way you do that is that holistic approach and reducing the factors that drive them. So
right. You may have covered this, and for some reason I just missed it. Is there a timeline for delivering the AI component of the project?
Yeah, so we are working with Dr. Greg Boyer right now and Dr. Stephen Shaw at SUNY ESF here in New York to get a grant going to process all of this data. Because like I said, 15,000 images is a lot to do by hand. And so we are hoping to get everything processed and the AI built and everything going by this summer, so we can get it into the hands of our of partners and volunteers and get down to the nitty gritty of testing for things like sensitivity and accuracy and false and positives and negatives. So.
Got a couple other questions here, but a couple people have asked, have we Clean Lakes Alliance interacted with Public Health Madison, Dane County on this? We're working on that. And I think that, what we're doing now is that we've been running this pilot program, and just like anything else that we do, we're an alliance, and everybody is at the table, and that includes Public Health Madison, Dane County, that's the cities and municipalities, that is the UW-Madison Center for Limnology. So, everything is shared. And that's sort of the goal of Clean Lakes Alliance, is that, we're able to maybe kind of move faster on some of these things, and then share the data with our partners, and potentially advance that at a faster rate, because some of those other agencies or cities have so many other things they have to focus on. And so the short answer is no, but the long answer is yes, as I think as we continue to develop any of these things, we share our data from Lake Forecast every year. And so as we develop this, that will continue to be shared with Public Health, Madison, Dane County, as well as Center for Limnology and everybody else that has a stake in the lake. So just wanted to kind of answer that. A couple other great questions
here. Can I just add on one thing to that, Adam? That's actually a really good answer. And the one thing we want to make sure is that we have something that can be useful to the health departments and that actually works. And right now we're still in the pilot phases of these projects, right? So we're still getting familiar with, the issues and how accurate this can be and how useful it is and so forth, and who can use it. So we really want to nail down that process and then give them all the data they need to make an informed decision of whether this is something they want to incorporate or not.
Yeah.
And like you said, working with these folks that have 1,000 responsibilities and we're only focused on one, it's a very different type of relationship, that it's like, hey, we're focused on this one thing, we need it done right now. And they're like, well, we have 1,000 other things we got to take care of. So hold your spot there in line.
Right, for sure. No, that's a great point. Someone asked, can you describe the citizen training that's needed before the HAB alert sampling?
Sure. Super straightforward. We show you the microscope, we ship you the microscope, and then you can either watch about a 30-minute video on how to use it, or we hop on onto Skype or Zoom or whatever you want to use, and we show you how to use it and make sure you're using it right. But within about an hour, you're up and running to play with it and start getting familiar with the microscope.
We've got a couple of minutes here. This is a very specific question, but I want to ask it because
sure,
maybe there's some, someone said maybe they missed it, but are we using computational neutral network for the image processing?
I don't know the exact answer to that question. So we are working, so I'm a ecologist, public health kind of toxicologist person. I dip my toes into many different things, but we are working with AI experts from Finland that are associated with our parent company Ramble, and they are excellent. And I think we are leaning towards a computer vision kind of AI, but we don't know yet what that means. And I personally don't know what any of that means because AI is not my expertise. And we haven't settled on a model yet, just because we just haven't had the chance to process enough images to get it up and running to see what runs best. Right. But we have produced a similar product for wastewater treatment called OpSize, and basically it functions in the exact same way, but they are detecting bacterial presence in water instead of cyanobacteria. And cyanobacteria are far easier to establish because they're just bigger, they're more unique in their structure and so forth.
Right.
So.
Maybe one or two more here. This one may have been covered too, and this person apologizes if they missed it, and I apologize if I missed it, but is the accuracy of the 10-minute results, how does that compare to a lab sample? Is the accuracy pretty strong in those 10-minute results?
So what we're doing right now with our results for HAB alert is basically the only thing we're really doing is replacing the human who is identifying these cells with a computer program, and you don't have to hand count these cells by hand anymore. So what you're basically doing is you're tracing the colonies And the model that we have developed is telling you how many cells are within that colony. And that tracing is ultimately going to be replaced by AI. So right now, when I showed that one graph, I think we had an R² value of like 0.88, meaning that, you know, the data is really, really tightly correlated with what you would see with a typical Fluoroprobe. This coming summer, what we're going to do is we're going to work together with SUNY ESF to basically say, okay, that's great with a Fluoroprobe, but how would it compare with a trained scientist doing cell IDs and cell counts, and see where that accuracy lies and so forth. So for right now, it looks really, really promising. Everything looks really tightly correlated, and the relationship is really, really close. But ultimately in 2022, what we're doing is getting down to numbers and accuracy figures and so forth to see what it looks like.
Sure. Well, the clock tells me we're at 9. So Igor, I want to thank you again for a fantastic presentation. We had a great group of people, 90, I think at one point I saw tuned in. So obviously a very exciting topic, or interesting topic for us that live here in the Ohio River watershed, dealing with those harmful algal blooms every summer. So thank you very much again for answering so many questions too. I want to remind everybody that our next Clean Lakes 101 is Wednesday, February 2nd, where the topic is Love in the Lakes. It is a very popular presentation that that's been given. This will be, I think, the 3rd or 4th year by Justin Chenevert from the DNR, who also used to do a little work with Clean Lakes Alliance. And it's all about how fish and plants reproduce in our lakes. It is a really, really fun talk. So if you can tune into that one, be sure to tune in. And then, but really that is part of our larger Frozen Assets Week, which is super exciting. Frozen Assets Week will kick off on Monday the 31st. We have a virtual presentation like this, Women in Water and Sustainability. So it'll be a panel talk featuring 3 women and a moderator from WKOW who are in the field of water and kind of what they do and you know, how they got interested in the field of water. So that's exciting. But every night at the Edgewater too, there's something going on, whether it's open skating or music on the plaza. So check cleanlakesalliance.org for information on that from that Monday the 31st through Sunday the 6th. Really quick before I sign off here, Saturday the 6th, though, is our big Frozen Assets Festival. We are so excited to be back on the lake at the Edgewater. Large show kites for Kites on Mendota, skydivers jumping out of an airplane. You can skate for free. You can try snowshoeing for free. You can try pond hockey for free. The Center for Limnology will be there with an ice science lab. A great way to just get outside, get a little space, get out on this big frozen lake and really spread out and enjoy it. And if you want to do something super unique, register for the Frozen Assets 5K, the only 5K in North America held entirely on a frozen lake. You can walk it, you can run it for time. You're still going to get a nice Land's End t-shirt. Kids 10 and under run or walk free with a paid adult. So just a great way to engage with the lakes in the summer and maybe start to get us excited for the days when it's warmer again and we can get out and swim. So if we didn't get to your question today, by the way, be sure to email us at info@cleanlakesalliance.org and we'll try to get it to Igor and find you an answer. Thanks so much. Happy New Year. And we hope to see you during Frozen Assets.